No, it's actually that. I tested it on the chapter series. I lost 2 marks for that. That's the only thing. Wait, so it's not I lost it.
Oh my by heart thing, bro. Bro, I can't by heart. See, I wrote some song. I did some solid notes for this, bro.
Hello.
Yeah, hello everyone.
Hi, sir.
Simply fact is that we had evidence to this song.
Shares, are you there?
No, he hasn't joined yet.
So I couldn't write the right into the phone. But we want two channels. So basically it makes a temporary thing.
Yeah, hi Shares.
Hi, sir.
Okay. So today we're going to begin with a new chapter, very important for Kvpy, which is called Quadratics. Okay.
Okay.
Okay,
I'm
sir.
calling it Quadratics because I'll be talking about quadratic polynomial and equation both. Okay. That's why
Okay,
we're
sir.
calling it as Quadratics. Okay. Now I think you have done this chapter in your
Adna?
Add month,
advanced.
yeah.
Yes, right. So, few things I would like to know from your end, so as to know at what level you know this topic. Okay. Any equation of this nature where a is not equal to 0 is basically termed as a quadratic equation.
Yeah.
Yeah.
Correct?
Yeah.
How many roots are there for a quadratic equation?
Two roots.
Can there be
No.
more than two roots for a quadratic
No.
equation?
No.
Okay. So let me show you something very interesting here. Let's say I give you a quadratic equation x minus a x minus b by c minus a c minus b plus x minus a x minus c by b minus a b minus c plus x minus b x minus c by a minus b a minus c. Okay. uh, Minus 1 equal to 0. Here a and b, a, b, c are distinct. They are distinct constants. Of course, they can't be same because if they are same, any one of them, any two of them are same, it will make the denominator of any one of them vanish. That is not permissible, right? Okay. Now here, there is something very interesting about this equation. Okay. You would see that a satisfies this equation. How? If I put x as a, the first term becomes 0. Second term becomes 0. Third term becomes a minus b into a minus c by a minus b a minus c, which is 1 actually. 1 minus 1 is 0, right?
Yeah.
So, first of all, you admit it's a quadratic
Yes.
because the highest degree
Yeah.
of the term appearing here is 2. So, this is a quadratic. Okay. A satisfies it. So, let's figure out the roots. A is a root. Can you see that b will also be a root? Check. This will become 0.
B minus B.
Yeah.
Yeah.
This will also become 0. 1 minus 1 again 0. So b will also be a root.
Yeah.
Okay. C will also be a root, right? Check. First term is 1. Rest both the terms are 0 0.
Okay.
Okay.
Alright.
Just one second.
So 1 second, I'll go get my headphones as well.
Sure.
So you can continue. It's okay. I'll be
Yeah,
back in
so
2 minutes.
my question is, how come that this quadratic has 3 roots? Any idea?
Well, it's not a quadratic then. I don't know. It's supposed to only have 2 roots. Is one of them equal to the other? Like B equal to C or
No.
A equal to C, something like that?
Even it is, I've already written that ABC are distinct.
Oh,
Yeah.
I'm not sure. Uh,
Sorry, sir. I'm back.
Yeah, so Shreyas, the question was, how come this quadratic equation has more than 3 roots? 3 roots.
Okay, sir. Yeah.
Okay, this is very surprising because a quadratic cannot have more than 2 roots, and there are 3 roots which I have figured out from this equation.
okay.
Is one of them what is that called? Imaginary? No.
See, do you know fundamental theorem of algebra?
Okay.
Fundamental theorem of algebra says that any nth degree polynomial cannot have more than n roots. Whether it is real or imaginary doesn't matter.
Yeah.
Now I'll tell you the answer here. This equation is actually an identity. Okay, there's something called identity theorem,
Okay.
which is very important. Identity theorem says that if a nth degree polynomial has n plus 1 distinct roots, then polynomial equation I must write, then it's an identity.
Mm.
Identity means not only n plus 1 will have infinitely many roots. Now, actually, I tricked you here because this expression, if you simplify, whenever you get time today, you try to simplify, you'd see that you'll get something like 0x square, 0x plus 1 minus 1 equal to 0, which is
Okay.
actually a very obvious thing that I wrote. And irrespective of whatever x you feed here, it is not going to matter because it's going to be 0 into that, 1 minus 1 equal to 0. So always it will be true. So
Okay.
A, B, C, whatever number you want to put, X, Y, Z, everything will work in this case. It's an identity.
Okay. Oh.
Yeah.
Okay. I actually camouflaged it in such a way that you were not able to identify that it was actually this expression. Okay. So it's like saying something like this, x square minus 2x is equal to x minus 2. Okay, looks like a quadratic equation,
The
but
cancel.
but it satisfies for all values of x because essentially I've written the same thing twice. This equal to this, which is universal truth.
Yeah.
Yeah.
This is true for all values of x. Getting the point?
Yeah.
Okay.
This is 1 second. Actually, I was recording this session for Dhruv.
Yeah.
Yeah, he's
Dhruv.
not
Yes,
there.
sir.
Yeah. Fine.
Yeah.
Yes.
So this is an identity, so we can have any infinite number of roots,
Yeah,
right?
yeah. Identity will have
Yeah.
infinitely many roots.
Yeah.
Mm.
Okay.
Yeah.
So this three-way just to confuse you, but in reality there will be many more.
Yeah.
Okay.
Okay. Mm.
Okay, fine. Now coming back to the concept of quadratic. Wrong. A lot of things running on the system, so it's
Yeah.
Yeah.
okay. Now roots of a quadratic. Before that, I would like to talk about the fact that when you say I'm finding the root of this equation, geometrically, what does it mean?
Where?
Finding the x-intercept. X-axis intercept.
Yeah.
Yeah, basically, you're trying to find out where these two lines actually meet, correct?
Yeah.
Okay. Now, you know that the first equation is that of a parabola,
Yeah.
Yeah.
and second equation is that of a.
Straight line. Yeah.
Straight line.
And what is that straight line, by the way?
The X.
X-axis.
The x-axis. Okay, the x-axis has the equation y equal to 0. And let's say this parabola is y is equal to ax square plus bx plus c. Okay.
Yeah.
Now, what decides that the parabola is opening upward or downward?
The sign on the A.
Yes,
Like
Sign
it's
on it,
negative.
right.
Yeah.
So
it's
this is
E.
when your a is positive, correct?
Yeah.
And the parabola will open downwards if your a is negative, correct?
Yes. Yeah.
Okay, so this is how the parabola will open when your a is negative.
Yeah.
Okay.
Mm-hmm.
Now, in either of the two cases, can you tell me what is the coordinate of the vertices?
Minus.
I mean, you can find the what is that? Line of what is that? Line of symmetry, which is minus b by 2a.
Okay.
Then substitute in the equation. That will give you the x coordinate.
No. Yeah.
Mhm. What is that? Can you find it out on your notebook?
Won't x be equal to minus b by 2a?
Okay,
Yeah.
that's fine. What about the y coordinates?
You have to substitute that.
Yeah. If you substitute
Okay.
okay, a
So-
into minus b by 2a.
If you're not aware of it, let me tell you it's minus d by 4a. What is d here?
B square minus 4ac? Is it? Or determinant? No?
No,
Okay. So
that is delta.
d is b square minus 4ac, correct? Same thing. Delta d discriminant.
Ayo.
This should be the discriminant.
Okay. Okay. Yes, sir.
Discriminant. Why it is called discriminant? Because it discriminates between the nature of the roots.
Yeah.
Yeah.
Okay. So irrespective whether the parabola is opening upwards or opening downwards, this is going to be the coordinate of the vertices. Correct? Yes or no?
Yeah.
Now this is very important because do you remember we had in your junior classes you would have derived the quadratic equation formula to find the roots.
Yeah.
What was the roots?
Minus b plus. Okay. Minus b plus or minus root under b square minus 4ac by 2a. whole divided by 2a.
How do you get to this formula? Are you aware of this?
Yeah, you use a splitting the middle term, right? Or it or something like that.
Splitting the middle term. Okay. How does splitting the middle term work here? We just know this equation: ax square plus bx plus c equal to 0. Only this
You
is known to
split
us.
the term, then you find out, then you get it as some like. Wait.
How do we get to this formula? Can you tell me, Shiz?
So I mean I can wait.
So
Okay, so we have to equate that to 0. Ax square plus bx plus c, if we equate it to 0.
Mm-hmm.
And
then won't you actually just do splitting the middle term and then factorize it into?
how can you split the middle term here?
That's what my question is. How do you split the middle term?
This is wait.
We can't do anything. So do we take, I mean, if we equate it to ax square plus bx plus c, if we equate it to 0, then write x in terms of all the other variables. How does that work?
Okay.
10 seconds.
This is called actually completing the square. So what you do is you take a common. Okay. So it becomes
Yeah.
Wait.
So I was partially right.
correct.
Yeah.
Now I can write this as a x plus b by 2a the whole square. Okay. Minus b square by 4a square.
Yeah.
Okay. If you again multiply a back, it will become x minus b square by 4a plus c equal to 0.
Yeah.
Yeah.
Okay. Take this term to the other side. So you'll become x.
Oh, okay. Wait. Okay. Yeah, I meant completing the square. I don't know why I said splitting the middle term for some reason. Okay.
Okay. So if you bring this a down, it becomes b square minus 4ac by 4a square. Okay. Which implies that x plus b by 2a is plus minus b square minus 4ac by 2a, correct?
Hmm.
Yes or no?
Yes.
Yeah.
Okay. So x can be written as minus b by 2a plus
Fine.
minus b square minus 4ac by 2a. That is nothing but minus b plus minus under root b square minus 4ac by 2a. Is that fine? This is how you get the formula.
Yeah. Got.
Correct? Now, here we had also learned in the junior classes that this plays a very decisive role in the nature of the roots.
Yeah.
So this term is actually given a short form name as discriminant d. Correct?
Yeah.
So if this d is greater than 0, you would realize that you will have two real and distinct roots.
Yeah. And if it's equal to 0, then it's one distinct root and
Less than 0.
less than no roots. Yeah.
Okay, so
Match.
if it is equal to 0, you have two real equal roots. Okay. And the third scenario is, we write it
No
here.
roots.
No, it has imaginary roots.
Third is if
Yeah.
d is less than 0, you'll get imaginary roots. Okay.
Yeah.
Now, couple of things here. Can you use the coordinates of the vertices to get to the same condition? That means, can you somehow show that these conditions come geometrically from the vertices of the coordinates of these vertices? Can
You
you
show
somehow,
that The
Can you
quadratic
somehow?
formula comes from that.
Sorry?
If you show us the quadratic formula comes from that,
No. I'm saying, can you show from the vertex that when d is greater than 0, it will have real and distinct roots, and d is equal to 0, it will have real and equal roots, and if d is negative, it will have imaginary roots. Can you show from the coordinates of the vertices? Okay, just a simple explanation required here. If you have a real and distinct roots, you can see them on the graph, right?
yeah,
Correct. In
Yeah.
that case, let's say if A is positive, if you want your graph to cut at two real and distinct points, don't you think your vertex y coordinate should be negative if A is positive?
vertex. Wait.
Don't you think your minus d by 4a must be negative,
Yeah.
Oh yeah, correct.
right?
Correct.
So if minus d by 4 is negative, that means minus d is negative.
Yeah.
That means d is positive.
Yes.
So
Oh.
this gives you the condition for having real and distinct roots.
Okay, got it.
Correct?
Yeah.
Okay. If your quadratic is just touching it. Acha, by the way, how does this same condition come even if your quadratic graph is opening downwards? See, in this case, when you have two real and distinct roots, minus d by 4a should be positive,
Yeah.
correct? But remember, a is negative over here, so if I multiply with 4a on both the sides, minus dA will be less than 0.
Yeah.
That means
Yeah.
d again will be greater than 0.
Oh, it's the same
So,
for every case. Okay.
yeah, the
Yeah.
situation remains the same irrespective of whether the parabola is opening upwards or it is opening downwards.
Okay.
Yeah.
Is that fine? Okay.
Yeah. Yes.
Answer.
Yes.
Now, what about the situation of you having equal real and equal roots? When real and equal roots are there, your parabola is actually touching the x-axis and going back, right?
Yeah.
Okay. Irrespective of opening upward or downward, it will touch and go back. Correct. Touching means y coordinate there should be 0.
Yes.
That means
Yeah.
minus d by 4a should be 0, which clearly
We.
Yeah.
implies d should be equal to 0.
Okay, got it.
Yeah.
So this is real and distinct, and this is real and equal. Real and equal. Is that fine?
Yes,
Yeah.
sir.
What if it doesn't have any real roots? If it doesn't have a real roots, that means it will be hanging in the air like this. Correct?
Yeah.
Even this will be hanging in the air, hanging down like this.
Yeah.
That means
Yeah.
in this situation, minus d by 4a should be positive, and in this situation, minus d by 4a should be negative. Okay, let's go step by step. Let's take the first situation when your a is positive. So this means minus d should be greater than 0. That means d should be less than 0.
Yeah.
Correct? In
Yeah.
this scenario, minus d by 4a should be negative. Now since 4a is already negative, if I multiply with 4a both sides, it will switch sign.
Yeah.
That means d again multiply with the minus 1, again it will switch sign. The inequality will flip, right?
Yeah. Mm.
So this implies that the situation that d is less than 0 for imaginary roots holds true even if your parabola is opening downwards.
Yeah.
Yeah.
Is that fine?
Got it.
Correct. Now here is something very important which comes out from the same situation. If you want your quadratic expression to be always be positive, or if you want your quadratic equation to be always negative, what are the conditions that must be fulfilled?
Okay. Okay, if it always has to be positive, then it okay. Would you say that it will not? It'll be b square minus 4ac will be lesser than 0 and a will be greater than 0.
Absolutely correct. So A would be
Yeah.
positive
What?
in this case and
Yeah.
discriminant would be negative. Understood?
Mm.
Okay.
Yeah.
What about this case?
It'll be the
Should be opposite. A should
opposite.
be
Yeah.
0 and d should be also less. Wait. Yeah, d should also be less
Mm.
than 0 and a should wait. If it's lesser than 0, then it will be a frowny thing, and if it is should not touch also.
So what should be the condition?
A is
A should be lesser than 0.
Okay.
yeah, that is for sure. Now D
Uh, Now if
squared.
d is lesser than 0, then
That means it's not touching, so it doesn't have to be. Wait, but then if it's less than 0, then it's negative.
d is less than 0. It doesn't have any real roots, right?
Yeah, it doesn't have to.
That should be true. Yeah, d should be less than 0.
Okay. Correct.
Yeah.
This is very important because direct questions have been framed on these conditions. Is that fine?
Yeah. Yes.
Yeah.
Okay. Fine. Now let's have a simple question based on this. Let's say I have a quadratic mx square minus m minus 2x plus 4. This quadratic is always positive. Okay. Find the values of x for which this is true.
And the values of x. Okay.
No, values of m.
Okay. Yeah. Okay.
Basically, you have to do whatever you said just now.
Yeah.
Done?
Yeah.
So 1 second.
I get an answer, but
Wait, hold on 1 second. 1 second. What is the quadratic equation you get?
I get m square minus 20m plus 4.
Yes, but I need to solve it. Hold on.
You can't solve it using the splitting the middle term.
You
Use quadratic formula.
Ayo.
Oh, wait.
See, m should be positive number 1.
Can I tell you the answer I got, sir?
Yeah, tell me.
I got m is greater than 10 minus 4 root x.
X is greater than
4 root x.
X is coming within x only.
4 root 6, sorry, 4 root 6. 10 minus 4 root 6.
I mean, it should be less than that, but greater than 0. Correct.
Yeah, but the thing is that I thought that the signs will change. Remember, we were doing problem and.
Oh, yeah. Okay, now, yeah.
So is m greater than 10 minus 4 root x, or is that?
Okay, let's discuss this. First of all, m should be positive.
Yes. Yeah.
Correct.
Yeah.
Secondly, the discriminant should be less than 0.
Yeah.
Yeah.
So what is the discriminant?
M minus.
B square minus 4ac should be less than 0.
So isn't it minus M minus 2? No, minus M plus 2. Isn't 2 minus M? No?
That doesn't matter because b square will be m minus 2 whole
Yeah,
square only,
right.
right?
Give me the same answer.
Yeah.
Okay, that means b square minus 4m plus 4 minus 4m should be less than 0, which means m square minus 8m plus 4 is less than 0.
Square minus 4AC.
And so-
Isn't it going to be 16M?
Yeah.
4 into 4.
I'm sorry. So minus 20, right?
Yeah.
Yeah.
Let me write it again. Okay.
Mm-hmm.
Now, if you have to solve this, basically you need to know its roots. Let's say m minus alpha and m minus beta are the roots. Correct?
Yeah.
So alpha beta here could be found out by using our quadratic equation formula minus b plus minus b square minus 4ac is 16 by 2a, right?
Yeah.
Yeah.
Okay. This is going to be 20 plus minus root of 384 by 2. Correct?
Yeah. 15 into 6.
Fine. Now, you can actually take a factor of 4 out if you want. So it's 10 plus minus root 96, correct?
Yeah.
Mm.
96 itself is 4 root 6, correct?
Yeah.
16, 4 root 6. Am I correct?
Yeah.
16,
Yeah. I got.
Fine. So now m should actually lie between alpha and beta if this is the case. Hope you are all aware of the fact that if you are solving this quadratic equation, assuming alpha is less than beta, the solution of this is m should lie between alpha and beta, correct?
Yeah.
Okay. Yeah.
So which
I mean,
is
okay, I've got it.
yeah, which is lesser of the two, 10 plus root 4 root 6 or 10 minus, so this will be beta and this will be alpha.
10 minus.
Yeah.
Okay. So your m should lie between 10 minus 4 root 6 and 10 plus 4 root 6. Switch on the off the fan.
Oh, I haven't. Oh, okay. What we when we've solved the equation, we usually do not do this. I mean, I've never. We didn't do this in add maths.
Hey, we did.
I don't remember putting it between alpha and beta. Did we?
No, we did do this, but then usually we got splitting the middle term quadratic equations, not
Okay.
well, yeah.
Got it. Got it.
Okay, got it?
Yeah.
Okay. Let's have another one. If the roots of this is 0, then show that
2 by b equals 1 by a plus 1 by c. Okay.
Okay, so that-
Okay, the roots of that equation equal 0.
Yeah, so basically you have to prove that A plus C into B is equal to 2AC.
Basically, you would have done your series sequence and progressions.
Yeah, I've done.
Yes, sir.
Okay.
Yeah.
In that case, you would realize that here A, B, C are in HP, right? Harmonic progression you have done? No.
Oh no, not done that.
No, I have not. Yeah.
I've only done arithmetic and geometry.
Yeah, APGP I've done.
That was-
Okay, what is the condition that your roots are equal?
B square minus 4AC equals 0.
Yeah. If the roots of this are equal, show that this is true. So for the roots being equal, discriminant should be equal to 0.
Yes.
Correct?
Oh,
So,
you modified the question in that way?
no, didn't I say they are equal?
Okay, if the 0 means
Yeah.
I got it.
Yeah.
Yeah. What is it?
Oh, didn't you notice the word I say equal? I didn't write it though.
Yeah. Because both them are 0, so okay, got it.
Okay. Now will you like to try it?
Yeah.
So B square means, sorry, you will have B square C minus A square minus 4 AC equal to 0. Correct?
Hmm.
Yeah.
Let me expand it. 4 AC I have taken together. Okay. So you'll get BA minus CA minus B square plus BC. Okay.
Yeah.
So if you expand it, you get a square b square, b square c square. Uh, will some terms get cancelled? Just check it out. Minus 2a b square c square. I'll write it down. Minus 2a b square c. This will give you minus 4a square bc plus 4a square c square plus 4a b square c and minus 4a b c square. Okay.
Mm.
Just check some terms are getting modified. I think this and this will be together. They are the same nature. So a square b square c square plus 2a b square c and any other term getting modified? Okay, no worries. So, huh?
Nothing.
Minus and minus 4a b c square. Correct?
Yeah.
Now, if you see ab square, bc square, and 2ac square,
Oh, yeah. Sorry.
in fact, I can take minus 2ac square. Okay, you'll find that this comes out to be a perfect square. If you
Okay.
expand it, you will get a square b square, which is here.
Mm-hmm.
You get b square c square, which is here. You get 4a square c square, which is here.
Yeah.
Then you get 2a b square c, which is here. Then you get
Yeah.
minus 4a b c square, which is here.
Yeah.
And finally, you get a minus 4a b c square. Uh, this two I took care of. This two I took care of, and these two, yeah. So it will be minus 4a square bc. So this is this term. Okay. So
Oh,
ultimately,
everything. Okay.
so
Equals.
ultimately
Got it.
you have to identify that this is actually the perfect square of this term.
Hmm.
Okay. Once it is a perfect square means you can write ab plus bc is equal to 2ac.
Oh, which is the same thing as the thing as
Yeah,
we.
divide by abc. So that will give you 1 by c plus 1 by a is equal to 2 by b.
Hmm.
Is that fine?
Yeah, yes.
Yes, sir.
Next. Relation between the roots and the coefficients. I'm sure you would have heard of this relation by the name of Vita's relation.
And her name.
Okay. Probably it will
No,
be
sir, I
obvious
haven't
when
done.
I tell you the relation. If you have a quadratic equation like this, whose roots are alpha and beta, you're aware that the sum of the root
Oh,
is
yeah.
minus. Hmm.
Yeah, we did this briefly. The way we went test on it.
Oh, yeah. I
Okay.
remember.
It was in the Who's Su Tong book.
Now, this very important thing that comes out from this relation is that if all ABC are real, okay, and let's say any one of the roots alpha or beta is non-real or imaginary. Let's say alpha is p plus iq. You understand I and all complex numbers?
Yeah.
Okay. Then remember beta will be of the form p minus iq. That means alpha and beta, if imaginary, will exist in conjugate pairs. Will exist in conjugate pairs. Understood?
Why?
Why?
Oh.
Why? Because if alpha plus beta has to give you a real quantity, then its imaginary part should get cancelled off.
Oh.
So if it has plus IQ, the other must have minus IQ.
Okay.
Okay. And product also will give you a real part. So you can see the only possibility when you can give a product also real is when it is of these forms. So I am sure you would have
Yes, sir.
a bit of complex numbers, I square is minus 1 and all that.
Yeah, because root of.
Yes, sir. I know.
So if you multiply it, you actually get p square plus q square.
Okay.
Okay. Just in continuation of this property, if A, B, C are rational, right? And if any one of the roots is irrational, irrational means there is a present of a surd. Okay. This will also exist in conjugate pairs. What I mean to say is that let's say this is 2 plus root 3, then the other one should be 2 minus root 3. Getting the point?
Yeah.
Remember, this property is to be only used when you are sure about these initial conditions. That is, the antecedent must be true.
Okay.
These conclusions do not hold true if any one of A, B, C is non-real. Let's say in the first case, or
Non-rational.
irrational in case of the second situation. Okay.
Okay.
Got it.
Understood? Okay. So this relation, as you would all know, is basically called the Vitas relation. Okay, and this can be extended not even to a quadratic but to any nth degree polynomial. So I'll give you an extended version of it. Extended version is, let's say, if you have any nth degree polynomial equation like this, okay, whose roots are alpha 1,
Okay.
alpha 2, alpha 3, all the way till alpha n. Okay, then sum of all the roots, let me write it like this, summation alpha 1 will be nothing but minus b by a. Here minus b by a would be minus a n minus 1 by a n. B will be the next term before this, right? So minus b by a. Okay.
Okay. Yeah. But
Sum of product 2 at a time will be okay. 3 at a time would be, can you generalize this? If I take k at a time sum,
A n minus k by a n.
because it's it keeps correct.
okay, this relation was called as the Vitas relation.
So the V is very nice.
Yeah, I practiced whole day for this.
Not as much as, our band is beautiful. Okay, anyways.
Yeah, of course you are leading it, right?
Oh no, sir. They replaced me with a robot.
Robot?
Yeah, they're playing the music instead.
On computer.
Yeah.
Why did they replace you?
Apparently, I was not good enough, so,
Okay. So, let's take questions on this. Okay. Question is, if alpha and beta are the roots of this equation. Okay, find the roots of, so find the equation whose roots are
Oh.
alpha square plus 2 and beta square plus 2.
One second, sir.
Do you know how to construct an equation when the roots are known?
Isn't it x minus alpha into x plus beta, something like that?
Okay, let's say if I give you the roots alpha and beta, the way to construct the equation is x square minus, it's the opposite way what you did actually.
Yeah.
Yeah.
This is how you can construct an equation, correct?
Yeah.
See, if you say alpha and beta are roots of ax square plus bx plus c, basically you're trying to say it's the roots of x square plus b by ax plus c by,
Yeah.
and just now you learned that b by a, yeah, b by is minus of alpha plus beta
Yeah.
and c by is alpha beta, correct? In other words, the equation whose roots are alpha and beta could be written like this also if you know alpha and beta, correct?
Yeah.
Yeah.
In the same way, you have to construct an equation whose roots are these two guys.
Okay, so wherever alpha is, there will be alpha square plus 2, and beta is a beta square plus 2, something like that.
Yeah, of course.
And then if we first find out alpha and beta, then.
Guys, okay, let's do this. So if you want to find out a quadratic equation whose roots are these, so you'll first do this operation. You'll find out this expression, correct?
Yeah.
But for that you need to know the values of these two, this and this, correct?
Yeah.
Now, alpha plus beta, according to this equation, you know alpha, beta are roots of correct? So alpha plus beta is 3 by 2
Yeah.
and alpha beta is minus 3, correct? Alpha square plus beta square plus 4 is as good as saying alpha plus beta the whole square minus 2 alpha beta plus 4,
Yes.
which is 3 by 2 square minus 2 into minus 3 plus 4,
Okay.
which is going to be 9 by 4 plus 10. That's 49 by 4.
Yeah.
And let's find out the product. So if I open the bracket, it becomes alpha square beta square plus twice of alpha square plus beta square plus 4. Correct?
Yeah.
Okay. And this term is actually minus 3 square, which is 9. Okay. And this term here, can I write it as 2 into 49 by 4 minus 4 plus 4,
Yeah.
which is nothing but 9 plus 49 by 2 minus 8 plus 4 is minus 4.
49 by 2 plus 5.
Yeah.
59 by 2.
Okay, yeah.
Okay.
That is what? Yeah, okay.
So your desired answer would be x square minus 49 by 4x plus 59 by 2, which is nothing but 4x square minus 49x plus 118 equal to 0.
Okay, so what you do is you just bring all of the product and the sum in terms of,
The known,
in terms of
values. Yeah.
yeah, the ones that we already know and substitute. Got it.
There's another way to do this problem by the use of transformation of equations. Okay, so I'll discuss it over here. Transformation of equations. This concept is useful not only in quadratic but also for theory of equations in general. Okay. What is this funda actually? I'll explain it in the same example. Let's say you say that alpha, beta are the roots of this equation, right? Okay. And you want to find out a equation whose roots are alpha square by 2 and beta square by 2, right? So you want to find this equation, correct?
Hmm.
Now, whenever you are seeing that both the roots are undergoing the same fate, same fate means whatever is happening to one root, the same thing is happening to the other root.
Yeah.
This is a typical example like this. Or it may be like, let's say alpha minus 3 and beta minus 3. So 3 is been subtracted from the first, then 3 is also subtracted from the other one. Okay. Or it could be like 1 by alpha, 1 by beta. Or it could be like alpha plus 1 by alpha minus 1 and beta plus 1 by beta minus 1. So I'm just giving you examples where I'm trying to show you what do I mean when I say the roots are undergoing the same fate.
Okay.
Okay.
Yeah.
So whenever such thing happens, we use transformation of equations. Right? How do I transform equations? So what I do first, take any one of the roots. Which one you want to take?
Alpha.
Alpha.
Yeah.
Okay. So alpha satisfies this. So 2 alpha square minus 3 alpha minus 6 should be equal to 0.
Yeah.
If you have taken alpha, take this root because both of them have the same fate, so it doesn't matter. Had you taken beta, I would have taken this. Okay. And now I'll start calling this as x. Okay. That
Alpha
means
square plus 2 is x.
x, yes. That means alpha square is x minus 2.
Yeah.
Correct?
Okay.
That means alpha is plus minus under root x minus 2.
Hmm.
I'll substitute this over here. So 2 alpha square is 2x minus 2, minus 3 is plus minus. Correct?
Okay.
Is this correct? Okay. Open the bracket, it becomes
Yeah.
2x minus 10 is equal to plus minus 3 under root of x minus 2.
Yes.
Square both the sides.
Okay. So 4x square plus 100 minus 20 minus 40.
40x.
3x, no, yeah, 9x minus.
Correct? If
Yeah.
you bring it to other
Yeah.
side, it becomes 4x minus 49x plus 118 equal to 0.
Hmm.
Why did I write x over here? Yeah?
Yeah.
You see, you get the same answer.
Okay, yeah.
So we had this answer. Now I've also got the same answer. Which one is faster?
This one.
See the power of transformation of equations.
Yeah. 1 second, sir. Can you just go to the top? I just need to look at copy this one.
This one?
Yeah, that's yeah, one.
How many schools are participating tomorrow?
Sir, only the NPS schools. And
Chairman's Cup?
and it's not
What is Chairman's Cup?
that's Chairman's Cup. But then they sometimes sports day also they participate, right?
Hmm.
Running event. That is if it doesn't rain tomorrow. If it rains tomorrow, everything is done.
Yeah, yes, sir. You
Done?
can. Yeah,
Yeah.
Yes, copied.
Yeah, 1 second. Can you just go down for a second?
This one?
Yeah, that's it. Yeah, you can change. Yeah, you can go to the next. Yeah.
Okay. So related to this, I can ask you a few questions.
Yeah.
Yes, sir.
Yes, sir.
Okay. Let's say we have this question. If this equation has roots alpha and beta, okay? If this equation has roots alpha and beta, find the value of 2 alpha minus 35 cube times 2 beta minus 35 cube.
Okay, so 1 second.
Okay, are you trying to expand this or something?
No, sir, I didn't.
1 second.
Okay, let's do this. See,
Okay, sir.
first of all, tell me a equation whose roots will be 2 alpha minus 35 and 2 beta minus 35.
Yes.
Again, try the same approach. Since alpha
Okay.
and beta are going the same fate, you can put alpha in the equation.
Mm.
Correct?
Yeah.
Yes or no?
Yes.
Now, put this as x.
Yeah, I did that. I used that method of
Yeah.
information.
I did that as well.
Alpha is x plus 35 by 2.
Yeah.
Put it back over here. So it becomes 2 x plus 35 by 2 square minus 35 x plus 35 by 2 plus 2 equal to 0.
Yes,
Okay.
I got that equation, and I found out the value of alpha also.
Found out the value of alpha was not required at all, I think.
Oh, after that, I would find the value of alpha, find the value of beta, substitute, and then get value of 2 alpha minus beta equal blah blah.
Okay.
Mhm.
Now,
Yeah.
if you expand this, you just need the product cube, right?
Yeah.
So from this equation, can I find the c by a expression? That would give me the product. That will give me this term actually. Getting the point? So
Okay.
a here would be the coefficient of x square, which if I'm not wrong will be half. This will be your a.
Mhm. Yeah.
Correct. And c will be nothing but the constant term. What will be c? C would be coming from this guy 35 square by 2. It will come from this guy also minus 35 square by 2. Correct.
Wait, minus? Wait, well, how? What 35 squared by 2? Wait.
Constant terms.
Oh, constant terms. Oh, that way. Oh. That's all you pay. Got it.
Correct.
Yeah.
Is that
Yeah.
correct, Shes?
Yes, sir. I'm eating, sir. Sorry.
Okay.
Yeah. Sorry,
Okay.
sir.
Correct. Okay.
Yeah.
And you'll get a plus 2. So this and this
Yeah.
will get cancelled, so it'll give you a 2, right?
Yeah.
So C will be 2. So C by A will be 4.
Hmm.
And what are you asked? You have been asked the cube of this, right?
Yeah.
This will be
Okay.
cube of this, which means you're cubing 4. That means your answer is 64.
Oh.
Yeah.
That's yeah.
That's
Okay.
it.
Sir, you know what I did wrong? I got all of this. I forgot to cube it properly.
Okay. So this. Oh, got it. Got it.
Got it?
Yeah.
Yes, sir. Sir,
Hmm.
sir, are you mad at me?
Sorry?
Are you mad at me?
No, why?
No, I'm asking. I'm eating, no sense. Sir. Sorry.
No problem.
Sorry, sir.
If you're hungry, you should always eat. I keep on saying in the class also, if somebody is hungry, please eat.
Sorry,
See,
sir.
at the end of the day, you're doing everything to eat only, right?
Yeah.
Yeah.
True.
All the effort is first satiating your stomach. Fine. So let's have another question now. If alpha beta are roots of, if alpha and beta are the roots of x square minus 5x plus 1 equal to 0. I'm sorry, it's minus 1. Minus 1. Okay. Then find the value of alpha to the power 15, alpha to the power 11, beta to the power 15, beta to the power 11 by alpha to the power 13, beta to the power 13.
So can you just go back to the previous code for a second?
Sure.
Yeah.
Okay.
Yeah, one second, just a second. Yeah. Yeah. Yeah, so you can change.
Okay. Any success?
1 second.
No, sir. 1 second.
See, there's a trick here. What is alpha into beta here? Can I say alpha beta is -1? Right?
Yeah.
So now what I'll do is, this alpha 11, beta 11, I'll segregate like this, okay? And I will introduce an alpha square, beta square over here. Does it make any difference because ultimately I'm multiplying with 1?
Yeah. -1.
No, -1 square.
That's yeah, correct.
Okay. Now when you expand it, it becomes alpha 15, then alpha to the power 13 beta square, beta 15, alpha square beta 13 by alpha 13 beta 13. Okay. Now from these two terms, and from these two terms, I'll take something common. So alpha to the power 13 you can take common. So alpha square plus beta square you'll get, and beta to the power 13 common, beta square plus alpha square.
Yeah.
Okay. Which actually gives you alpha square plus beta square by alpha to the power 13, beta to the power 13 by alpha to the power 13, beta to the power 13, which will get cancelled off,
Oh, yeah.
giving you alpha square plus beta square. Alpha square plus beta square is nothing but
Alpha square.
okay.
Okay.
Yeah.
Oh, wow. Yeah.
Which is 25
Mm.
Yeah.
Yeah.
minus 2 into -1, so answer is 27.
Mm.
Got it.
Quite interesting question.
Yeah, very interesting.
Okay. Next is conditions for common roots. Acha guys, before we move on, as I already told Arushi and Shreyas also in the class, we would need extra classes for JEE Main and Kvpy because right now my entire focus is on Kvpy.
Yeah.
Because Kvpy is round the corners. In November you'll be writing, I think, correct? You all fill the form?
Yeah.
Okay. So,
I didn't fill it yet, sir. I'll fill it.
Abe, date is gone.
Oh.
Last date was 22nd of August.
So, oh God. Okay.
So wait, you're not going to write KPPI then?
How will
I
you
don't know.
write? Then you will write in next year now. Shreyas, why do you do this?
I don't.
I'd forwarded the link on the group also.
Really? Oh, I didn't see it then. Oh God. Okay, wait.
Just wasted a year.
Yeah. I was so busy with this thing. Oh. Okay.
You know, two of the students, they were trying to fill on the last day. They didn't know that the time was 5 o'clock. I asked on the group also a couple of times that you have filled the form. I think Dhruv said yes, Arushi said yes.
So I didn't see only. Wait. What was I doing?
God knows.
Okay. Oh God.
I think I had sent 3 weeks ago, right, Arushi?
Yeah, you had it.
Yeah, I was so busy with all of this events and all. I forgot. Oh God.
What are you gonna do now?
31st July I had sent.
I don't know. I'll see.
Okay.
I can't do anything now, can I?
No. Probably you may have to go and check in the institute itself.
Yeah.
Okay, let's say we have these two quadratic equations. Okay. And let's say they have one common root. Let's put a condition having for no, let's say they have two common roots. Two common roots means both roots are same.
Yeah.
Okay, so let's say this has also alpha beta, this has also alpha beta. Okay. So what is the relationship between A1, A2, B1, B2, C1, C2 if they have both the roots common?
Can you equate them by any chance?
If two equations have same root, what do you
X would be.
comment when the two equations have the same roots? Don't you feel that their coefficient must be proportional?
Oh yeah, A1 by A2 is B1 by A2.
Yeah.
Okay. Now let's figure out the condition for one root common or one common root or exactly one common root. One common root means alpha beta, let's say, and this has alpha gamma. Okay.
Okay.
Yeah.
This means one root common. Exactly one root common, you can say. Exactly one root common. This means both root common. Now, what is the condition for exactly one root common? Okay. Let's say alpha is the common root. So, alpha will satisfy both the equations.
Yeah.
Hmm.
Okay. Then what I can do, I can put alpha square as, let's say, P, alpha as Q. Okay.
Hmm.
Yeah.
So can I say this equation will convert as A1P B1Q plus C1 equal to 0? and A2P plus B2Q plus C2 equal to 0.
Yeah.
This is like a simultaneous equation in P and Q.
Yeah.
Yeah.
Can we solve it by using our substitution, elimination, or cross multiplication method?
So what do I do now?
In this case, solve for P and Q.
No, not that.
Then
Kvpy.
Kvpy probably have to link. You just check. Is it active yet? I don't think so. 20.
I went to the website now. When I click on it says click here for registration and application login.
Mm-hmm.
I went there and it says candidate login only.
Candidate login means when you get your admit card, you can log in there.
Yeah. Everything else is there, sir. All the this thing and
Just go and talk to the exam coordinator of Kvpy in IISc.
yes, sir.
Be careful of all these days. Next year, so many dates will come out.
Yeah. So next year will be harder, right? But then we don't have to take bio.
Yeah.
Are you studying for bio?
I mean,
Huh? You are?
no, I mean, like somewhat.
Yeah, so I'm using the book that you gave me, the career point thing. For bio.
You know elimination method? Sorry, you know cross multiplication method of solving quadratic equation? Sorry, simultaneous equation?
Awesome.
Cross multiplication. So
Yeah.
we know matrices.
Matrices method, you know?
Yeah.
Okay.
That's it, I
But,
guess.
but in that case, you have to find inverse and all, right?
Yeah.
Yeah.
Okay. There's an easier method which is called the Kramer's rule. Okay. I'll discuss this method with you. See, in Kramer's rule, what do we do is we write down the name of the variables like this: P minus Q and 1 like this. Okay. Put a dash. Fine.
One always.
1 always, yeah. Then what do? We hide this entire column. Okay. Right. Let's write like this 1 1. Okay. Then do B1 C2 minus B2 C1. B1 C2 minus B2 C1. Cross multiplication, just like you do in determinants.
Okay.
Okay. Now hide. This is done. Now hide the column under Yeah, sorry. Now hide the column under this. So this is hidden. Okay. Then you see A1 C2 minus A2 C1.
A1 C2 minus.
Okay.
Yeah.
Then hide 1 also. Then we have A1 B2 minus A2 B1. Okay. So from here we get P value as B1 C2 minus B2 C1 by A1 B2 minus A2 B1 by comparing these two.
Yeah.
Okay. By comparing these two, you get Q as A2 C1 minus A1 C2 by A1 B2 minus A2 B1.
Hmm.
Mm.
Okay.
Oh, okay.
Yeah.
Now you know that P is alpha square and Q is alpha, correct?
Yeah.
So
Yeah.
indirectly you're trying to say P is Q square.
What? Yeah.
Correct?
Yeah.
Yeah.
Just a second. Can you write that condition? P is equal to Q square here.
Yeah.
Oh,
Okay.
yeah.
So this, so P is equal to Q square. So this is equal to Q square. Okay.
Yeah.
So if you see this term individually will get cancelled with one of the square terms denominator. So it will become B1 C2 minus B2 C1 into A1 B2 minus A2 B1 is A2 C1 minus A1 C2 the whole square.
Hmm.
Okay. Now this is a
Yeah.
condition actually that we need to remember for the two equations to have one root in common. Okay. But this condition
Mm.
itself is huge. I mean, there's a lot of chance that you'll forget it. Correct.
Hmm.
So are you aware of this
Yeah.
determinant symbol that do you know this A1, B1, A2, B2 symbol like this?
Yes.
It means
So
A1,
which one?
B2 minus A2, B1.
Yeah. Yeah.
You're aware of this?
We use it cross.
Yeah.
Okay, fine. So the same expression here, I would write it in some different fancy way. A1, A2, B1, B2. Then again a determinant B1, B2, C1, C2 is equal to C1, C2, A1, A2 whole square. Now this is easy to remember.
Yeah.
Yeah.
Cool?
Yes, sir.
Okay.
That's C1, A1, C2, A2, right?
Oh, I'm sorry. C1, C2, A1, A2. Yeah. Today also when I told you, Shes is saying I'm going to fill it soon.
So, I mean, it's okay. I'll work towards the next KVP one.
But it says that the last date for pay. Okay, I think the 20th August was the last date.
Yeah, 20th August.
Hmm.
And I think, oh wait, I have the website open here. But it's so irritating, sir.
What is irritating?
No, like, because, I mean, I don't know, something is irritating.
Are you irritated that you didn't do it?
Yeah, but okay, it's okay. I'll work towards the next one.
Well, this is a big learning for you that first paperwork has to be done and then preparation has to happen.
Yeah.
Okay, anyways. If there exists at least one common x, if there exists at least one common x,
Get that?
if there exists, this is symbol of there exists,
Mm-hmm.
at least one common x which satisfies x square plus 3x plus 5 equal to 0, and this equation where a, b, c are natural numbers. Okay. Then a is to b is to c is option A 1 is to 3 is to 5, option B 3 is to 1 is to 5, option C 5 is to 3 is to 1, option D data insufficient. Any idea?
Hmm.
1 second, sir.
Actually, no, I'm confused.
See, what type of roots does this equation have? What is the nature of the roots?
Wait.
Um,
B square minus 4AC. Isn't it negative?
Yeah,
yeah.
it's imaginary.
That means it has imaginary roots. Correct?
Yeah.
And since the coefficients are all real, 1, 3, 5 are real, so if let's say one root is P plus IQ, other has to be P minus IQ.
Yeah.
Yeah.
So if one common X is satisfying this, and even these are real because A, B, C are natural numbers, correct?
Yeah.
Yeah.
That means both the roots should be the same, right? So at least one basically gets converted to both the roots.
Wait, why again? Can you repeat that, sir?
Because both are equal, right?
No,
Yeah.
no. Roots. If one is equal, the other will also be equal because it cannot happen that only this is equal, this other one is not. Because wherever they will go together, right?
Yeah.
If the coefficients are real.
Okay.
So that means what? That means A by 1 should be equal to B by 3 is equal to C by 5. That means then the ratio of 1 is to 3 is to 5.
Yeah.
Yeah.
Okay. Okay, so because both of them have to be equal because one is imaginary and the other is
No,
real.
both have to be imaginary because this discriminant is negative.
Yeah, okay, got it.
It can't have one root imaginary and the other root as different imaginary, correct?
Oh yeah. Okay, got it. Got it now.
Next question. If x cube minus mx square minus 4 equal to 0 and x cube plus mx plus 2 equal to 0 both have one common root, then find the values of m.
Answer.
1 second, sir.
Yeah, I got an answer, but I'm not really sure it's correct.
What is your answer?
Is it m equals plus or minus 4th root of 9 by 2?
Fourth root of 9 by 2.
Oh my god. Okay, let's do this. See, I have an idea in mind. Can you multiply the second equation by x and add it to the first one?
By x and add to the first one.
Yeah, just multiply this with x and add it with the first one. So x to the power 4 will come, correct? mx square will get cancelled.
Hmm.
Okay, so you will
Yeah.
have 2x and x cube term also will be there. I'm sorry, forgot x cube. Then you have a 2x minus 4 equal to 0, correct?
Yeah.
Yeah.
Okay. If you see 1 is going to satisfy this, so x minus 1 is going to be a factor, correct?
Hmm.
So let's find out the other factors, okay, by doing long division. So x cube minus x cube, subtract 2x cube plus 2x minus 4, 2x square, 2x cube minus 2x square, 2x square plus 2x minus 4, then 2x, 2x square minus 2x, 4x minus 4 plus 4, okay? So this will be x cube plus 2x square plus 2x plus 4 equal to 0, okay?
Hmm.
Now if you check, minus 2 will also satisfy this, because minus 2 if you put here, you get a minus 8,
Plus 60.
are my signs proper? Minus 8 plus 8, and this is minus 4 plus 4, correct? Satisfying it?
Yeah.
Yeah.
That means you can further pull out a factor of x minus 2. In fact, you can factorize this and check it was easily factorizable. Okay.
Hmm.
So x minus 1, x plus 2, x square plus 2. Okay. Now, of course, this cannot give a real root. Only real root could be 1 or minus 2, right?
Yeah.
Mm.
Okay. If you put a 1 over here, you get 1 minus m minus 4 is 0. That means m is equal to minus 3. Okay.
Hmm.
This will also give you the same. So you don't have to put it both the places. Correct? If you put a minus 2, what do you get? If you put a minus 2 here, what do you get? Minus 8
8
plus 4m minus 4 is 0. Yeah, again m is minus 3. So minus 3 is the only value for which it can have real root. So answer is m is minus 3.
So you can't do the matrix way for this.
What is the matrix way?
We done that. We written down for
No,
one
but this is a
common, right?
cubic equation, na?
Oh, that's why you can't. Okay.
Yeah, the thing works only for quadratic. So this is
But-
just an extension of the concept. The examiner wants to see whether you can extend the concept, and you should never try to implement a formula directly. In fact, Kvpy questions can never be like that. Okay, you have to learn the application and various
Okay.
manifestations of the same concept.
Okay.
Fine, then we'll stop here. Okay.